Bismillahirrahmanirrahim. Welcome back to my channel. This video is going to be on GnuRadio, and we're going to learn a very basic program, sort of like a Hello World program for GnuRadio. And since GnuRadio is a software that deals with signals and specifically RF signals, in this program, what I'm going to do, you will find a similar program, but this is much upgraded version of a program of this particular flow graph. Why? Because we have a signal source, and we're going to actually look at how does these signals sound like. How do they sound? How does the spectrum of a signal looks like? What does a waterfall graph, how does a waterfall graph look like? Time sync signal looks like, and constellation diagram of different waveforms. So the most common waveform that we have available on our signal source block that is available in GnuRadio, if I were to look at the properties of this, is actually you have a constant signal, then you will have a sine, cosine, square, triangle, and sawtooth. These are the signals that I can give to my that I can generate using GnuRadio. Now, how do they sound like? We're going to actually explore that, and we're going to look at their spectrum, time sync graph, oscilloscope graph, waterfall graph, and constellation graph. Now, if you notice something, I think I already made a video on it, but just to touch this subject a little bit. Now I'm using something called a Qt GUI chooser block, and this is the block that is available here. So for example, and then this way I'll have a chooser button, a drop down menu where I can choose my waveform. So if you were to look at this particular chooser button, so I'm calling this a waveform. You can just simply go ahead and type here waveform, and these are the different types of waveforms I can generate. So code 101 is for sine wave, code 102 is for cosine, 103 for rectangular or square wave, 104 for your triangular wave, and 105 for your sawtooth. These are the default values that you should know. When you want to use a chooser block, you don't need to type it. 101 as default will give you a sine wave in your chooser block. So these are different type of waves. We're going to actually hear them. We're going to actually look at their waterfall graph. We're going to look at their time graph and frequency graph and things like that. So 101 for sine, 102 for cosine. So these are different codes which are associated with different type of waveform which is available in my signal source right here. So waveforms, you can just simply type in. So once you get this, I have typed this. I'm calling this chooser block waveform. Second thing, anything that is underlined, you can control it with a slider block. So I can control the frequency with frequency block. Freq is given from 100 to 20 kilohertz. So we want to actually monitor. So because our audible frequency is from 20 hertz to 20 kilohertz, so I want to actually hear hear those frequencies as well, depending on the type of waveform that I have chosen. So amplitude is there, so I'm going to change this to amp. So these are the two things that is controlling my frequency and amplitude. The other cool thing about this block is that that I modified. I can just simply use a normal signal source, multiply constant block, audio sync, and GUI sync, but I have used a toggle button. So you can use a toggle button. The state of your toggle button when you choose this is actually it's a false state, which means your button is closed. So just simply incorporate that. So that button is there. So I'm just incorporating this. So this button will appear on your flow graph at the output of your flow graph, and when you press the button, it will turn on, it will turn off. So that's what the state of this button is. So right now, this multiply constant block, the signal that is coming in, there is nothing coming. So this button is actually turned off. There is nothing which is going to my audio sync, which is my speaker of my laptop, and nothing is going to my GUI sync, so I won't be able to see anything. So let me run this flow graph so you'll know exactly what is happening onto that flow graph. I'm going to turn on my volume, and I'm going to play this. So right now, this is what it looks like. So I just call this flow graph as being a hello world graph and signal. So this chooser block is types of waveform that you can generate. So let's say I want to generate a cosine signal. By default is cosine. There's nothing, no matter how much you change this frequency, because the signal is coming in, but multiply constant block is blocking it because this is being controlled by this button. So when I turn on this button, you're going to start hearing your frequency. So this is right now is being generated at 2500 or 2.5 kilohertz, 2.5 kilohertz. I can go up to, as you can see, the frequency is changing. You have a frequency, the sound is also changing. This is what you need to observe. Same thing with the waterfall graph, same thing with time domain signal as well, because your signal amplitude is 0.05. So I can turn on this amplitude and so on. Let me just zoom in on it. So right now 0.2, this is what my swing is, 0.2, and this is the constellation diagram that looks like. This is a complex signal, real signal actually. So right now, so let's leave it at 1 kilohertz and let's see how does these other signals sound. So this is how cosine sound. This is a 1 kilohertz cosine signal. This is how it sounds. Right, this is the frequency spectrum. You're at about 1 kilohertz. This is that waterfall graph. This is your time domain graph. This is your constellation graph. Now, let's change this waveform to sine. Sine and cosine are generally same, so we're good. Now let's change this to square wave and let's see how does it sound. Does the sound changes? So just this is how a 1 kilohertz signal at a square wave signal sounds like. Of course, when you change the frequency will change, the sound will change. Let's go back to 1000 for a square wave. This is the waterfall graph. Right? This is your time domain graph. This is the constellation points. Now let's change this frequency to triangular wave and let's see how does a triangular 1 kilohertz triangular wave sounds like. This is much dimmer because this is how the spectrum looks like. This is what a waterfall graphs look like. This is what a time domain graph look like, and this is what a constellation looks like at 1 kilohertz. Definitely you can change the frequency. You can see the change in frequency. Let's go back to 1 kilohertz. Alright, now let's change this to sawtooth. And this is what sawtooth sounds like at 1 kilohertz. Definitely you can change the frequency. This is the waterfall spectrum. This is the frequency spectrum. This is what time domain signal look like. And these are the constellation points. I can increase the amplitude. I can change the frequency. This is what a 9 kilohertz sawtooth signal sounds like. So when you start exploring signal, this is probably the best way. This is probably the best flow graph that you can use. And I just simply, my flow graph is still running, but I just simply turn off my button. This value is false using a toggle chooser block. And in this way, you can turn on and off signal if you want. So this is how the signal sounds like. And this is what these common signals that we use, sine, cos, sawtooth, triangular wave, square wave, this is how they sound like, and you can actually hear them, you can see the spectrum and things like that. So if you have any questions, leave it in a comment section, and please don't forget to like and subscribe to my channel, and thanks for watching.